Good afternoon, class. Thank you. You can sit down. All right, in today's lesson, we are going to look at the homework you were given in the previous lesson. We'll look at the answers, and then we'll look at the exact trig ratios for angles 30, 60, and 45 degrees. All right, we'll start from the back. Patrick, your answer for question 1 on the homework, please.
Um, 4.3 centimeters.
4.3 centimeters. Correct? Yes? B. Lester.
9.3 inches.
9.3 inches. C. Gabriel. You didn't do this question. Livingston.
meters.
4.4 meters. Right, that's question 1. A, B, and C. Right, question 2. Kila.
59 degrees.
Say that again.
59 degrees.
59 degrees. Esther, letter B.
15.9 degrees.
50 point
15.
15. C. Jake.
22.7 degrees.
22.7 degrees. Okay. You all agree so far with questions 1 and 2? Number 3, Rita.
7.7 centimeters.
Altitude 7.7 centimeters. Number 4, Daniel.
2.8 centimeters.
Number 5, Boromeo.
33.3 centimeters.
Okay, 33.3 centimeters for number 5. Number 6 we did in the previous lesson, so number 7. You have to find the length of the distance D. Natasha,
2.09 centimeters.
2.09 centimeters. Number 8, Siegfried. AB first.
AB is 3.73 meters. BD is 5.47 meters, and BC is 5.87 meters.
BC is 5.87.
87.
Okay, any questions on the exercise, on the homework? If there's anything that is not clear? I know that there are answers in the textbook. I hope you're not just looking at the answers and not doing the work. That's cheating. You all know how to do question 7? Okay. So no answers, no questions. Good. What I'd like you to do for the next thing, because we are going to look at the exact ratios for the angles 30, 45, and 60 degrees. Okay, the ratios for angles are actually standard. Like if you are to find, say, sine of 50 degrees, it's always the same. It cannot change. There are ways to get the angles, but the ones that have exact values which are easy to find are 30, 45, and 60 degrees. So this is what I want you to do. You're going to draw an equilateral triangle of side 2 centimeters. And then we are going to use it to find the exact trig ratios for sine, cosine, and tangent of 30 and 60 degrees. Okay, I've got it done on the board. I want you to do it in your exercise book, please. Okay, note you can actually use any equilateral triangle, but it's the smallest one you can use is the one that has sides 2 units. Okay, that's why we use this one. But even though even if you use let's say 4, 4, and 4, the value will still simplify to the exact ratio. You done? Okay, the next thing to do is to draw a perpendicular line. Sorry, in an equilateral triangle, we know that if the sides are equal, the angles are also equal, and each angle is okay. In an equilateral triangle or an isosceles triangle, if I draw a perpendicular bisector or a perpendicular line from one of the vertex, it will bisect the base. So if this is triangle A, B, and C, and I draw a perpendicular line from the vertex A, it will bisect the line BC at right angles. So this one is now equal to 1 unit, and this one is also 1. So I'll just write that down, 1 centimeter and 1 centimeter. The line will also bisect the angle 60 degrees. So this angle is now 30 degrees, and this one is also 30 degrees. Now, I want you to use Pythagoras Theorem. We are going to use one of the triangles. These two triangles are now exactly the same. They are congruent triangles. I want you to use one side of the triangle to find the length of the perpendicular height. Quick. And we'll leave it in exact form. Okay, what's the value for h? What's the length of the perpendicular height? Huh? Root 3 centimeters. And you do that by saying h is equal to the square root of 2 squared minus 1 squared, which is 4 minus 1, it's 3. Okay, I'm now redrawing the one of the triangles in here. Okay, according to this diagram, looking at 60 degrees first, sine of 60 degrees, Garonamo, is equal to what according to this diagram?
Root 3 over 2.
Root 3 over 2. Okay. Cos of 60 degrees, Megan?
1 over 2.
1 over 2 or a half. Tangent of 60 degrees, Agnes,
Root 3 over 1.
which is root 3. Okay, root 3 on 1 is root 3. Okay, with your calculator, if you are going to press sine 60, find sine of 60 degrees is exactly the same as if you divided root 3 by 2. I think it's 0.866, I don't know. Okay, that's root 3 over 2 is also 0.866. So these are the exact, root 3 on 2 is the exact value or the exact trig ratio for sine of 60 degrees. Okay, cos 60, if you press your calculator, it will give you 0.5. Okay, and tan 60 degrees will give you 1.732, which is the square root of 3. Okay, these are standard, which means you are required to remember this. You are required to remember this, but the best thing to maybe be able to do is to know where it comes from, because if you forget, you can always draw an equilateral triangle, find the perpendicular height, and then use it to find the trig ratios for 60 degrees. Okay, the reason why I'm saying that they're important is because in grade 12, we look at angles which are greater than 90 degrees, especially those that are related to 60, 30, and 45. The values are exactly the same. We're going to show you when the time comes. Okay, those are the trig ratios for 60 degrees. Now, the trig ratios for 30 degrees. Sine of 30 degrees. Ponrele?
0.5.
Okay, which is a half according to this diagram. Okay, cos of 30 degrees. Peter?
Root 3 over 2.
Root 3 on 2. Tan of 30 degrees. Andrew?
1 over root 3.
1 over root 3. All right, I want you to have a look at these values and see if you can see any relationship or work out any relationship between 60 and 30 degrees. Look at the exact trig ratios. What can you see? George, what's the first thing that you can see? What can you say about the trig ratios for 60 and 30 degrees?
They are opposite.
What do you mean they are opposite? Explain further. Solomon, help.
If you use sine 30 degrees, the answer will be equal to cosine 60 degrees. And the cosine 30 degrees, if you use that, you'll get the same answer as sine 60 degrees.
And what about 10?
The turn will be vice versa.
Vice versa. What's vice versa? Left and right? Up and down? Come on, give
Inversely
me a mathematical.
proportional.
Huh?
Inversely proportional.
Reversely proportional.
I mean, inverse.
Not really.
The reciprocal of.
Reciprocal, that's better. Okay, 10 of 60, sorry, yeah. 10 of 60 is the reciprocal of 10 of 30, or 10 of 30 is the reciprocal of 1060. Okay, 60 and 30 are what type of angles? They are,
Complementary angles.
Complementary angles, very good. I want you to remember this because I'm not going to write it. It's important. For complementary angles, their sine and cosine will be the same. Their, okay, this one cosine, sine will be the same. And their tangent will be the reciprocal of each other. So, if I asked you, cos 72 degrees will be equal to what? Sine of Velma?
Sine 18.
Sine of 18 degrees, very good. And if, let's say sine of 31 degrees, what is it equal to? Hekoi?
Cos 59 degrees.
Cos of 59 degrees. If I gave you an angle and I said cos of 45, no, too easy. Let's say cos of 20 degrees is this is not true, I'm just giving you an example. If cos of 20 degrees is 0.1235, and I asked you to find sine 70 degrees, Chutali, what would your answer be?
Will be the same.
Same as what?
Cos 20 degrees.
Okay, 0.1235. Clear? Okay, so this is true only for complementary angles. Their sine and cosine will be exactly the same, and their tangent will be the reciprocal of each other. Okay, now the next thing we are going to do, I want you to sketch an isosceles triangle, and it has to be an isosceles right angle triangle with sides 1 centimeter. Quick. Find the hypotenuse of the triangle, and then we'll look at sine, cos, and tangent of 45 degrees. Okay, see if you can find sine, cosine, and tangent of 45 degrees using the triangle that you've drawn. Now, Marco, what's the hypotenuse of this triangle?
Root 2.
Root 2. Okay, it's the square root of 1 squared plus 1 squared. That's root 2. Okay, I'll just write it on the side. This is how you get it, 1 squared plus 1 squared, the square root of 2. Okay, note it's 45 degrees because if these two sides are equal and this is 90, then those angles are obviously 45 degrees. Okay then, so sine of 45 degrees. Kyle?
One over root 2.
1 over square root of 2. Good. Kiapin, cos of 45 degrees.
One over root 2.
1 over root 2. Okay, you will also note 45 and 45 are complementary angles because they are complementary angles, their sine and their cos will be equal. Okay, tangent of 45 degrees. Gabriel?
One.
1. Opposite over adjacent is 1 over 1, which is 1. Okay, and if you press a calculator, you will get tangent of 45 is 1. That's because it comes from here. Even if you used another isosceles right angle triangle, let's say if this was 2 and 2, these angles will still be 45 and 45. You will still get the same ratio. You will actually have to simplify and you will end up with 1 over root 2. Whatever length you use, you will still get the same ratio. So it's standard. Okay, so sine 45 is 1 over root 2, cos 45 1 over root 2, and tan 45 is 1. Okay, there is a table here that I need you to fill in the information. So if you can draw this and then fill in the information that is given. It's a summary table. Quickly draw it in your exercise books and fill in the values. Okay, you should have in this space a half root 3 on 2 and 1 over root 3. Here 1 over root 2, 1 over root 2 and 1. Here through root 3 on 2, a half and root 3. You ready to move on? Okay, next. In trigonometry, if you are asked to say square sine of 45 degrees, let's say sine of 45 times sine of 45 degrees. Okay, it is usually written as sine with a 2 at the top, 45 degrees like that. So that means sine of 45 degrees squared. Clear? Okay. The next exercise, in the next exercise, you are to use the table above, which is the summary table. Given that sine 30 is a half, cos 30 is root 3 on 2, and tangent of 30 is root 3, and also the trig ratios for 60 and 45 degrees. You are to fill in, to answer the following question. Say, for instance, if you are asked to find, let's say, sine of 60 squared plus cos of 30 degrees. Okay, sine of 60 squared and cos of 30 degrees squared. Okay, sine of 60 we know is root 3 on 2. So root 3 on 2 squared plus cos of 30 is also root 3 on 2. Root 3 on 2 squared. Root 3 on 2 squared plus root 3 on 2 squared. Okay, what's the answer for root 3 on 2 squared? Margaret? Give it to me as a fraction.
1.5.
1
1.5.
1.5. Root 3 times root 3 is 3. Remember, sets, and 2 times 2 is 4. Okay, so 3/4 plus another 3/4 is equal to Geno. 3/4 plus 3/4, the denominator is the same. 6 on 4. Okay, 6 on 4, which is also 3 on 2. That is what you are required to do in the first exercise. You have to use the table. I do not want to see this sine squared 60 plus sine 60 squared plus cos 30 squared, and you're just writing equals 3 on 2. Your calculator can do that for you, but I don't want you to do that. You have to use the table and use working out, show the working out to find the answer. Okay, there are, for question 4, questions 1 to 16, maybe more, I don't know. 16, there's 17 and 18. It's very easy. And there's 19 and 20. And then there's question 5, 1, 2, 3, 4, 5, 6, 7. And then there's question 6, 1, 2. And then there's an exercise in your textbook, 38.4. Questions 1, 2, 3, 4, 5, 6, 7, 8, 9. And so you've got a lot of homework to do. You'll have enough time to do that work. So the key word to the pilot teacher is exact ratio. Please stand. Good afternoon, all the hardworking students. Thank you.